why do we want superintelligence? You know, in your mind, when everybody is saying it is going to slip out of human control, it is dangerous. And I again want to share with the audience that everybody who's catalytically at the center of this have been saying, from Sam Altman to Elon Musk to Demis Hassabis to Dario Amodei to all of them, are saying that there's a 20 to 30% chance that it could lead to human extinction. And yet one is hurtling towards superintelligence. You want it as well. Why do we want this, Yann?
This desire for domination has nothing to do with intelligence. It has to do with the fact that we are a social species, the same as baboons and wolves, and to some extent dogs. So this has nothing to do with intelligence. It's just something that, you know, evolution built into us for survival.
Good morning, everyone. I'm Shoma Chaudhury. I'm the founder of Synapse and Lucid Lines. And with all our partners and my entire team, I want to extend a very, very warm welcome to all of you to Synapse. It is absolutely splendid to have you here at a very, very important moment in all our lives. And I want to thank you for flying in from across the world and across the country to come together here to discuss all the range of issues that we're going to over the next 2 days. Synapse was really birthed out of an idea that we are at a hinge moment in our lives as a civilization and as a species. It is put together by people who are not really from science and technology, and that, in a way, makes us the perfect mediators of this conference, because the issues around science and technology is permeating our lives across all spectrums, from geopolitics down to our cellular level, our emotions, our energy, our relationships with each other and ourselves, relationships between power structures, and who will control it. It is a time of immense opportunity and immense anxiety. So the idea that really drove Synapse was that science and technology is the hand of God in our lives. It is reshaping everything from life to death and everything in between. And yet, a lot of decision makers across fields and all of us as ordinary citizens, we often feel that science and tech is not something that we relate to, that is pertinent to us. It is a conversation either for laboratories, for IIT or Silicon Valley geeks, or it is for governments. But we wanted to take this extremely powerful phenomenon outside of boardrooms and labs and government decision-making bodies and into the public square. Because what is going to be discussed over the next 2 days are both immense opportunities as well as costs. It has implications for who we are, as I said already, not just as big corporations or countries, but us at our most intimate selves as human beings. And so this is a range of technologies and cutting-edge science that is converging. We are just speaking here today in the backdrop of the India AI Summit, which brought together some of the most powerful people on the planet today. We are in the midst of a massive build-out, infrastructure build-out. It is being called as the largest infrastructure build-out in human history. Just this year, some of the biggest AI companies is going to spend more than $700 billion on infrastructure to create superintelligence. Superintelligence is machine intelligence, which will surpass human beings. But that's just one phenomenon. Alongside are incredible, exciting advances in the biotechnologies and life sciences. In this conference, you'll have a scientist who's cured a baby by precision medicine of just that baby's DNA. We're able to re-engineer who we are in our bodies, in our minds, and in our social behavior. That conversation has to be in the public square. So we think of Synapse as almost constituent assembly debates because these are new nation states, new locations of power being born. And as I said, it is a location of immense anticipation, opportunity, but also anxiety. So we are going to have a fantastic array of the most cutting-edge minds that have come from across the world. And you in the audience are, again, decision makers that cut across fields. And so it is a very powerful synaptic moment over these 2 days, which will, I hope, permeate outwards. I always give this statistic at every edition of Synapse that every human being has more than 86 billion neurons and 7,000 synaptic connections per neuron. So that's in the order of magnitude, many, many trillions of synapses, which is able to draw meaning, synthesis, deduction, and arrive at purpose. We are in ourselves a cosmos. And so we have more power packed in this room than we imagine. And I hope that these conversations will be windows into ripple effects that will transform us and the way we relate to this new phenomenon and hinge moment in history. And now we're going to move into the first session of the day, which really is a kind of trigger point for everything that we'll discuss over the next 2 days. At this very moment, we're talking about the most intense capital ever in human history being put into the creation of superintelligence. As I already said, just this year, it's going to be $700 billion of investment by just a few companies. And that we're talking about America because we don't even know at some levels what China is doing. But what is the goal of that? It's superintelligence, which is to create machine intelligence, which will surpass what we are capable of as humans. Now, around that, again, is an incredible excitement of bringing in an age of abundance, which is the word we always hear, a time when none of us will need to work, everything will be done for us. There will be ample, medicine for diseases. Disease will be cured, cancer will be cured, climate problems will be cured. But at the other end of that spectrum is an anxiety about who will control this. Will this machine intelligence escape human control altogether? So that's one order of argument. And beneath that is another, that is this AI hyperbubble really a bubble waiting to burst? Is this entire LLM frenzy, which has been sort of pistoning all the capital, public discussion, governmental concern. As I said, we're speaking at the backdrop of the AI Summit. Is all of that really chasing a red herring? Is this the wrong path altogether? At the heart of that debate is a giant of a technologist and scientist, a man who's called the godfather of AI, and he's here with us today to decipher, to predict, to share with us the vision. He's a kind of outlier, really flying against the wind of common wisdom today. So it's a real privilege and pleasure to have him here. Ladies and gentlemen, please join me in welcoming Yann LeCun, a godfather of AI, now leading one of the most cutting-edge advanced machine intelligence labs. It's a real pleasure to have him here with us. Thank you so much for being here, Yann.
Pleasure.
Yeah, I'm sorry we're running a little bit late. It's because of the technology again, but I won't explain that. I really wanted to start at the absolute hot point of this entire phenomenon of machine intelligence and superintelligence, Yann. I just shared with the audience that we're in the midst of the biggest infrastructure build-out in history, trillions of dollars being put into LLMs, ChatGPT and Anthropic's Claude and all of that. But you've been saying that this is really a dead end. Share with us what you think about LLMs and why you're running against the wind.
Well, so there is nothing wrong with investing in LLMs and making them better, because they are very useful.
Can the audience hear him?
No? Yes?
Okay. Just a bit louder, yes.
Okay, let me repeat this. So there's nothing wrong with investing in LLM and developing products around them. Those things are very useful. And of course, there's a lot of development going on there, which is fine. There's a lot of investment made in infrastructure to run LLMs. And there is a question of whether that investment will ever be recouped by revenues generated from LLM. And it's a big question. I'm not the best person to answer that question. I don't know. I think there is a lot of investment that is due to a fear of missing out, and the fact that if you have cash, you better make sure you're not missing a big opportunity. So I think that's what drives it. Whether the revenue will come to justify this is not clear. Now, what I've said too is that LLMs are very limited in their capabilities, although they are useful. They are very limited. So the discourse that we've heard that LLMs are a path towards superintelligence is false. It's just not going to happen. We will have superintelligent systems. It's not going to happen next year. It's going to take a while. And it's not going to be LLMs. It's going to be other systems, some of which I'm working on. But
right. But Yann, this is the most mild I've ever heard you on LLMs. Do share with the audience your true, forget about the investments and all of that, just LLM as a technology. What is your idea of them? You've literally said that in 5 years, LLMs will be dead. Help us understand why something that the entire world is chasing, that you think it's the wrong thing. First, describe LLMs to us in your vocabulary.
Okay, so again, they're very useful. We all use them, right? I certainly use them. So there's just not a path towards superintelligence. Why? So first of all, why do they work, right? So LLMs are essentially trained to predict the next word or the next token in a sequence of words. And the particular way in which this is done allows us to train those systems at a very large scale on a lot of data and very large models. And those models are large because the way they work is that they accumulate knowledge. It's a kind of memory, if you want. It's an intelligent memory that you can retrieve from by asking questions, and it does a little bit of reasoning, but very limited. But it's basically a memory. It's a system that has learned by rote. It's not particularly smart, but it has accumulated a lot of knowledge, and that's very useful for many of us to access knowledge. Okay, but the only thing an LLM can do is just produce one token after the other. Now, of course, modern LLMs have kind of more sophisticated things that are bolted onto them to allow them to understand images, for example, or to reason a little bit in domains like code generation, mathematics, and a few other domains where the language itself has a lot of structure. But in terms of the type of reasoning that we think as humans, they really can't do it. And so it works because predicting the next word in a text is really not possible, right? You can't predict exactly which word will come after a sequence of words. But you can produce a score for every possible word, a probability distribution, right? And that's how you handle uncertainty. That works for sequences of discrete symbols. It doesn't work for the real world. And so LLMs do not understand the real world. They don't really reason. They don't have intuition. And so that's what I'm trying to fix.
I want to share with you that, as I said, Yann is being the mildest he's ever been on LLMs because he says it has less intelligence than a rat or a house cat. As I said, he's also said that it's going to die in 5 years. So that's pretty emphatic predictions on something that the entire world is chasing, Yann. So, you've already said that it only has a kind of predictive a capacity to retrieve intelligence, a database of intelligence. It can't think on its own. It can't act. But you are now moving us to a completely new world model. And I want you to share that idea with the audience. But before that, I want to push you a little bit more on this, Yann. Your own mentors, the other two who are called godfathers of AI, which is Geoffrey Hinton and Yoshua Bengio. You kind of grew up with them, They're saying that LLMs are supremely dangerous. Geoffrey Hinton literally broke from Google so that he could speak his mind. He thinks it could lead to the extinction of humanity. Every big, from Elon Musk to Dario Amodei to, everybody who's part of this world has been saying that this could lead to extinction of humanity. What are they seeing that you are either missing or don't agree with?
So, okay, so first of all, the thoughts around this, both from Jeff Hinton and Yoshua Bengio, who are good friends, who've known each other for decades, has evolved. They're much less negative about this than they used to be in terms of the potential dangers, right? Jeff, at some time in the past, thought, maybe he still does, that LLMs have subjective experience and that they were not far from human intelligence. I think he's changed his mind a little bit because when he's being asked, when are we going to reach human-level intelligence with AI, he says, 10 years, decades, right? So he's not that kind of optimistic about the ability to really reach that goal. Yoshua is projecting ourselves in the future. He says, there's going to be future AI systems. There may be superintelligence. That might be dangerous. We need to think about this now. And my counter-argument to this is that future intelligence system at the level of superintelligence will be extremely different from what we see at the moment. We're not going to get, as I said before, we're not going to get to superintelligence by just scaling up LLMs, training them with more data, and refining them more. It's going to be a different system. And so it's as if you were asking the question, how are we going to make transatlantic flights on a jet airliner safe in 1920 when jet engines were not invented yet? It doesn't make any sense. You can't make a system safe unless you know how it's designed. And we don't know how it's going to be designed. So, well, I have my idea, of course, but who knows? So that's the first point. Now, for Sam Altman, Dario Amodei, I think Sam's idea has also evolved. Same with Demis Hassabis. He used to tell that we're going to get to superintelligence, it's just around the corner. Now he says 5 to 10 years at least, and there's going to be a need for a few conceptual breakthroughs before we get there. It's basically what I've been saying forever. So I think we agree on this, Demis and I. Sam Altman has been sort of evolving on that. I think the singular point is Dario Amodei, who's claimed we're going to have a country of geniuses in a data center next year. I think that's just completely false. It's a complete misunderstanding of really what intelligence consists of.
But Yann, so now we'll move to, why we should have superintelligence in the first place. But again, it's like Demis Hassabis, Sam Altman, all of them are not speaking in this long range. They're saying like in 2 years, we are going to have AGI, you know,
That's only Dario.
Sorry?
It's only Dario. No, nobody else claims that.
So you're basically saying all of this is a lot of bullshit, to use your own language.
We're not going to have superintelligence in 2 years.
I want to tell you there are no rules of play over here on manners. You know, you can really say what you think, Yann.
So, I mean, okay, an important point is we are going to get superintelligent machines. There's no question at some point, okay? The most optimistic view, I think, is, you know, at least 5 years from now, you know, perhaps 10 years, and, you know, some people claim more than that. It's almost certainly more complicated than we think, because it's always more complicated than we think. I've been around in AI long enough to have observed multiple generations of revolution of AI technologies, and every time there was sort of a new paradigm in AI, people said, that's it, that's the secret. We're going to, within 10 years, we're going to have machines that are smarter than humans. And it's happened 4 or 5 times over the course of history of AI. Every time it was wrong. And every time it was because, you know, you imagine that your paradigm is going to be pushed. And that goes back to the 1950s, where some of the pioneers of AI that had a huge influence, Alan Newell and Herbert Simon, produced a program that they called very modestly the general problem solver. This was 1958. And they said, you know, we can reduce intelligence to a problem of, you know, formulating a problem and then searching for a solution. We just wrote a program that can do this for any problem. That's it. But it wasn't it. It was much, much harder than they thought.
So, Yann, you just very emphatically said that there will be superintelligence and it will arrive, you know. So one, you've said that the path that everyone else is taking is the wrong path. But before I come to your path, why do we want superintelligence? You know, in your mind, when everybody is saying it is going to slip out of human control, it is dangerous. And I again want to share with the audience that everybody who's catalytically at the center of this have been saying, from Sam Altman to Elon Musk to Demis Hassabis to Dario Amodei to all of them, are saying that there's a 20 to 30% chance that it could lead to human extinction. And yet one is hurtling towards superintelligence. You want it as well. Why do we want this, Yann?
Okay, so first of all, the motivation for building intelligent machines, at least my motivation is threefold. The first one is basically discovering it's a scientific question, discovering the mechanisms behind intelligence. It's purely a scientific question. You know, it's one of the big scientific questions of our time. There is, you know, what's the universe made of, what's life all about, and how does the brain work? Those are the 3 big scientific questions of our time. So how does the brain work? If you are an engineer and a scientist, the only proper way to do this is to build a system that is intelligent, right? So that's how you solve the scientific question. Now there is a technological question, or kind of a impact question, which is, you know, how do we build intelligent systems so that they improve human intelligence, they increase the amount of intelligence in the world. Intelligence is the commodity that is in the shortest supply, that, you know, we can improve the well-being of humanity by increasing intelligence regardless of whether it comes from machines or humans. So that's kind of the motivation. And, you know, there's another motivation, which is that the best way to interact with intelligent machine is to have them have an intelligence that is similar to humans, so that we're familiar with you know, the kind of interaction we can have with them. But also in some domains, they can be smarter than us. But they will assist us in the sense that we'll ask them questions, we'll give them tasks, they will accomplish those tasks, answer those questions for us, and that's it. They will work for us, right? They will be our staff. It's like all of us will be, well, many of the people in the audience here are leaders in business or academia or politics, and, you know, some of us walk around with a staff of helpers, most of whom are smarter than us. That's what's going to happen to everyone. We'll have a staff of intelligent virtual people, basically, helping us at all times. So, and, you know, that has to be a good thing. Now, for the question of, is it going to take over the world, right? I think there is a big confusion that should not be made, which a lot of people are making, because the only intelligent entities that we are used to interacting with are humans. So we assume that if a system has an intelligence at the same level as humans, it will have the same characteristics as human nature. And human nature comes with a lot of hardwired drives and desires that were built into us by evolution for the survival of the species. Because we are a social species, we need to be able to interact and influence other members of our species, either by prestige, like academics, or by power, by domination, okay? And in a lot of social species, like baboons, it's mostly domination. It's not so much prestige. In humans, it's more prestige. But the point is, this desire for domination has nothing to do with intelligence. It has to do with the fact that we are a social species, the same as baboons and wolves, and to some extent dogs. So this has nothing to do with intelligence. It's just something that, evolution built into us for survival. So when we build intelligent machines, they will be intelligent, but they will do our bidding. They're not going to want to take over. They're not going to want to dominate, unless we hardwire this into them. And of course, we're not going to do that.
But Yann, last night we were having a big debate about this, that your vision is that you will create a new model, and now I'll bring you to talk about that, but that you will hardwire the laws of the way human beings have laws, social laws. You will hardwire laws into these machines. So I'm going to come to that, but I just want to ask you one more, because there's so much of discussion about this capacity to really extinguish humanity altogether, which is that why are these companies then, we are not here sitting discussing AlphaFold, Last year, Pushmeet Kohli was here from Google DeepMind, and when it can do protein prediction, when it's a narrow tool-based AI, we won't have an entire conference of, decision makers debating that. I think why this is a debate that is spread across the entire planet is because these machines are being created in the likeness of human beings, able to speak to us, we are speaking to them, they've become our lovers, our friends, our therapists, our confidants, our rebellion partners and all of that. So are you saying that even in that way, the personality of these machines is a wrong direction? Will your world models have no human personality? Will it just be like a robotic arm doing what you want it to do?
Okay, so first of all, the reason why LLMs seem to behave like humans is because they are trained with text produced by humans, and they're trained to reproduce that, right? So whether we like it or not, whether it's by design or not, it's trained with that data, and it will, due to the statistics of the data, reproduce human behavior with all of its good sides and bad sides. The type of system I've been working on for the better part of the last 15 years and making some inroads over the last few years is a completely different design, which is based on what's called world models. This phrase is quickly becoming kind of a buzzword in the sort of AI research. And in my opinion, this is the new paradigm. This is the way we're going to build agentic systems, systems that can reason and plan, systems that understand the real world, which LLMs are incapable of doing. So if you want to build what's called an agentic system, right, it's a bit of a new word as well. So a system that does not just answer questions, but can take actions, either in the physical world through a robot or in the digital world by interacting with the internet or whatever. You need such agentic system to be able to anticipate and predict the outcomes or the effect and the consequences of their actions, okay? So given the current state of the world and an action that you imagine taking, we all have a model in our head of what's going to happen when we take the action, right? You know that if I push on this bottle, it's going to slide. If I push on this table, it's probably not going to move. But if I push on this bottle at the top, it's going to flip, right? We have this intuition. We taught ourselves all of this, how reality works in the first few months of life. In around 9 months, babies learn about gravity, that an object that is not supported will fall. Okay, so all of those things we learn mostly by observation, a little bit by interaction. And as it turns out, building a world model of this type, right, a thing that, given the state of the world at time t and an action that we imagine taking, predicting the state of the world at time t+1 after we've taken the action, that turns out to be way more complicated than predicting the next word in a text. Why? Because the world is messy. The real world is really, really messy. It's complicated, it's high-dimensional, it's continuous, it's noisy, and we cannot use the same techniques that have been so successful for text. We cannot apply them to the real world. We need to use other techniques. And this is why we have systems that can pass the bar exam, that can ace International Math Olympiad in mathematics, and do things like that. But we still don't have domestic robots. We still don't have self-driving cars, level 5 self-driving cars. And we certainly don't have self-driving cars that can be trained to drive themselves in 20 hours of practice like any teenager.
You do have self-driving cars in San Francisco now, but I don't want to bifurcate over there now, Yann. I just want to share with the audience that for those of you who are not familiar, and many of you will be, that the world model is actually the one that Yann is building, and you're again saying in 2 years or 5 years you're going to be ready with that. In a way, is even more powerful than the LLMs because they will be able to operate in a physical world, anticipate, have common sense, not be constrained by its data set, but be self-learning. So in many ways, Yann, you're describing something even more powerful than the LLMs. And when they are out there, walking the planet, you said this is going to be the decade of robotics. I come back to the issue, so there's all, you've already outlined all the good that can come of it because it's intelligence of a higher order. But you're describing something more powerful than LLMs. Then how will it be controlled,
More powerful, but safer and more controllable. So I actually call this architecture that I've been building with my colleagues, objective-driven AI architecture. And what it means is that it's built around this idea of world model, right? So a system that can anticipate the consequences of its own actions. And so if you have such a world model, you can have a system estimate the current state of the world by perception, just looking or measuring sensor inputs, whatever it is. You get some idea of the state of the world. Then using your internal world model, you can have the system imagine or predict what the result of a consequence of actions that it imagines taking is going to be. Now you can feed this to an objective function, something that determines whether a task has been accomplished or not, okay? And then you can plan a sequence of actions, an optimal sequence of actions that will accomplish that task. So a system built along those blueprints can do nothing else but accomplishing the tasks you give them. Okay? This is not like an LLM. You cannot control an LLM. LLMs are intrinsically unsafe. Now, of course, they're not very smart, so they're not very dangerous. But they are intrinsically unsafe. They cannot really be controlled. Whereas the system I'm proposing, you give it a task, it knows whether the task has been accomplished or not. It imagines what sequence of actions to perform to accomplish this task, and then it accomplishes those actions. So now you can make this subject to safety guardrails, and the system will not be able to escape that conditioning of having to satisfy those safety guardrails. And this is very different design from LLMs, for which there is no guaranteed guardrails that it will satisfy.
So just to pursue this for a moment more, and then we'll move to something else, is that we were having an argument with Yann last night because Yann's idea of the world models is like very obedient children because he's going to hardwire these laws into them and they'll only do the bidding of them. And I said, what about if someone else hardwires something else into them? And we all have children who don't live by our rules or what we taught them as children, they break free. So, Yann, you said something which you said, oh, then it'll be my good AI versus someone else's bad AI. That sounds pretty apocalyptic. You may be a good man, Yann, setting good objectives for your world model. There could be innumerable others who learn that technology and set different goals for those models. So, are you all thinking about these scenarios?
Well, that's the history of humanity, right? Some country, civilization, region invents a technology, and then some other one tries to copy it or invents a new technology. And then if there is any kind of conflicts between them, it's whoever has the best technology who wins. That's the history of humanity. So I'm not saying anything that's new there, that there may be eventually, badly intentioned actors or simply people who have sort of different interests than ours, who build intelligent systems, and then it's, you know, my good AI against your bad AI. It's inevitable.
So, Yann, you left Meta, and you know it made global news. What triggered that leaving? You know, it was one of a very, very powerful partnership. What made you leave Meta?
So, a number of different things. So, first of all, you know, Meta is a great company to work with and to work for.
Yann, I think on the flight here, you took a polite pill, you know?
Say again, I'm sorry.
I said on the flight to India, you seem to have taken a politeness pill, you know? Someone's hardwired new laws into you, because this is not how you speak elsewhere.
No, this is really heartfelt. Like, you know, working at Meta is like working for family. At least it was the, you know, for a number of years that I was there. I was there for 12 years, right? I created the fundamental AI research lab, FAIR, and ran it for a few years. And then after a few years, in 2018, I stepped down and became an individual contributor again. Basically, I became the chief AI scientist. So I was not, I hate management. Okay, that's the reason. And I'm not so good at it. I think I'm more motivated to work on the underlying science and technology. So, so what's happened over the last year is three things. First of all, we started having really good results with this approach of, you know, based on world models and planning and a new architecture, a non-generative architecture that I call JEPA, Joint Embedding Predictive Architecture. And we call this entire project AMI, internally, Advanced Machine Intelligence. So a number of people were working together towards this program. And what's happened over the last year is that Meta decided that strategically, they just wanted to catch up with the rest of the industry. There was, you know, a bit of a disappointment with the performance of Llama 4, and, you know, Mark just wanted to have, you know, one of the top LLMs. So it sort of redirected a lot of the R&D operations towards catching up with the rest of the industry, and, you know, hiring people from other companies, OpenAI and Google, creating a new organization called TBD Lab, putting Alex Wang in charge of all of AI strategy. And that sort of de-emphasized a bit the sort of slightly longer term strategy of the type of architecture I was working on. So even though Mark himself and Andrew Bosworth, the CTO, were extremely supportive of the project I was working on, the general atmosphere in the company was not as favorable. And the company was, you know, kind of changing its modus operandi a little bit, becoming a little more secretive, you know, less open source, etc. And so the fact that I realized that we had really good results and most of the applications were in industry outside of the main interest of Meta, which is really only focused on connecting people with each other, it made sense for me to take this project outside the company and shift it into high gear. And so a few months ago, I went to see Mark and I told him, like, you know, I'm leaving the company. It makes complete sense. He understood this, and because he's interested in the result, we're actually partnering with Meta.
So, Yann, we'll unfortunately have to end here, but I just want to leave the audience with a kind of emphatic assessment of where we are, a situational report. On the LLM front, do you think that this is a bubble that's going to burst?
There's two kinds of bubble. The first bubble is the bubble of, you know, LLM are going to be expanded to AGI or superintelligence. That is a bubble, okay? It's not going to happen. Let me tell you why it's not going to happen. If you take all the text available on the internet today, publicly, it's the quantity of information is about 10 to the 14 bytes. So this is a 1 with 14 zeros. It would take any of us about 500,000 years to read through all of that. This is what an LLM is pre-trained on. Okay, and then there is some more phases around this. Now, think about a human baby. A human baby mostly learns about the world through touch and vision, at least for people who can see, through the senses. Just from vision, the amount of information getting to the visual cortex in the first 4 years of life, this is 16,000 hours of wake time, is 10 to the 14 bytes. It's about 2 megabytes per second going from the retina to the brain. In 4 years, a child has seen as much data, as much information as the biggest LLMs in the world. Now, that information is much more low level, if you want. It's much more about the physical world than about high-level concepts that we can express in language. But that's the point. It's very important to learn this, and LLMs don't learn this stuff. This is what human intelligence is based on. This is what's missing. This is why, again, we have systems that can pass the bar exam and answer questions. We don't have self-driving cars. We don't have domestic robots. We don't even have robots that are as smart as a cat, right? So that's the gap that we need to plug, and that's what I've been working on.
Well, thank you very much, Yann. You know, one could talk to you for much longer.
Thank you.
We haven't even begun to debate the nature of intelligence in the first place, but I do want to share with the audience that Yann is here. He's predicting a much more powerful model, his world models. The first, you said, would be out in about 6 months, and then in a 5-year time frame, the world models that Yann is speaking of may be walking amongst us. And so, as we said, these are really urgent and germane conversations, and it's been a real pleasure to have you here, Yann. Thank you very much.
Thank you.